Good? All right. So yeah, so don't use Edge.
Well, it did through Edge. It's just like I had 15.
Right, but Edge still sucks. Don't use Edge. Like, what about it do you like?
I don't know.
Like, you like it better than Chrome?
Well, I like hated Internet Explorer, so I used to use Chrome all the time.
Okay.
When Edge came out, I started using Edge, and I just like it better.
Is there something specific you like better about it?
I don't know if it's like the interface itself or like how it's more Windows feel.
Oh, that makes it even worse. I hate the Windows feel. Man, I hate like even the Windows 10, the new Start menu. They just took all the crap that used to be on like the whole tile interface thing for Windows 8 and just stuffed it into the Start menu.
We can do your Start menu back.
And so the Start menu is like 3 or 4 columns wide. It's ridiculous.
I mean, like I have mine minimized to just like I took a bunch as much of the crap out as I could.
What would be better actually if you just had a Mac?
I mean, I have a Mac, but I only use it when I want to be a special snowflake.
A special snowflake? That actually sounds awesome. What does that mean? Am I missing a?
When I need to feel unique.
Is it a laptop or an iMac?
iMac. It's
iMac.
old though, so
Oh.
it's worthless. Well, it's not worthless because I can use Xcode on it,
But it's oldish.
it has Sierra. I mean, it's new enough. That
Oh,
Sierra.
so that's not that old.
It's 2010, I think. So it's like in its last 1 or 2 OS updates.
Okay, so we are here, right? Okay, so we decided that we were going to write Towers of Hanoi. We looked at Towers of Hanoi last time, right? Kind of how the game works, and we decided that we also looked at stacks last time. We saw that implementation of stacks is actually pretty easy. All right, now for Tower of Hanoi, each tower is effectively a stack, correct? But it's a stack where the push maneuver has a caveat to it, right? When we try to push something onto a tower, it's only going to allow that push if the disk that's currently at the top of the tower is smaller than the disk that is larger than the disk we're trying to push on. Right, we're only allowed to put smaller disks on top of larger disks, not the other way around. All right, so we're going to go ahead and we're going to implement our tower. But before we do that, we need to implement a disk. All right, so disk should be fairly easy to implement. So we'll create a new class here. We'll call this guy disk. And we're going to have a private int. Well, we call this guy size for the disk. Then we'll have public disk, and this guy will take in an int size. And we'll set this dot size is equal to whatever size was passed in. And let's go ahead and maybe give ourselves the ability to display a disk, something like that. Okay. Now, what we probably want to do, we're not going to spend too much time on making this look good. So yeah, let's just make it called display. So public void display. And maybe this guy takes whatever the size is and he creates like that many equal signs concatenated together or something like that to kind of show the size of the disk. So maybe what we can do here is we can do a string for display, and we'll go ahead and build that guy here. We'll say this dot display is equal to the empty string for int I is equal to 0, I is less than size, I plus plus. This dot display is equal to this dot display concatenated with an equal sign. And then down here we can say system.out.println display. All right, and just before I forget, let me pop open Android Studio and let it update the background in case it needs to do anything while we're writing this. No updates.
It's not real.
That's not real.
Start doing something.
Check for updates. Is it crashing? I think it might be. Oh no. Okay, so it looks good there. Check for updates. Big money, big money. Android Studio, brought to you by the people who made Blackboard.
I was on a Reddit post last night about like the biggest problems in like largely used pieces of software, and the top one that came up was Blackboard.
Really?
Yeah, everybody was talking about it.
I clicked update there.
I guess at one point there was a problem with Blackboard where if multiple people were putting in grades for the same class, there was like a data synchronization issue where if somebody updated one score and then somebody else updated a different score after them, it would overwrite the first person's score that they updated with 0.
Oh, well, that makes sense.
Yeah.
Make sure grades are a little bit random.
Yeah.
I actually use a random number generator for all my grading anyways. Okay, he's doing his thing. All right, so this is our disk. Let's go ahead and just test that guy out here real quick. So we'll create a couple of disks. And this will be, maybe we'll do a size 3. What size 6, size 9? Run this. All right, looks legit enough. I think we can probably roll with that for our Towers of Hanoi game. All right, so that is a disk. So now we need to have a tower. A tower is going to have a collection of disks. It's effectively our implementation of a stack, but a Tower of Hanoi stack, you know, the extra little caveat. So let's go ahead and we'll say new tower. Well, new class, call this guy tower. All right, and so this guy is going to be an implementation of a stack. So we'll have our, now we could always extend stack here, but since we're gonna have to rewrite push anyways, then we might as well just write it from scratch. So we'll say private disk. So now the things that are at the top of our stack are in fact disks. With that in mind, we're probably going to have to update our disks to kind of know about the next disk, so that this guy actually asks, you know, works like a normal node. So really, our disks are kind of like nodes. So we'll have a private disk, next disk, something like that. And when a disk first is created, we'll say this dot next disk is equal to null. Okay, so that's equivalent to what we used to call next node, right? But we happen to have a collection of disks instead of a collection of nodes. All right, go back into our tower. So we're going to have a private disk called top. And then we'll create our constructor here for our tower. So public tower, we're going to say this dot top is equal to null because there's nothing on there yet, right? Then we're going to have our public, probably Boolean for push because we might want to know whether or not it worked. So when we try to push something onto a tower, we might want to get a little feedback as to whether or not it was a successful push or that wasn't a legal move, something like that. So we'll call this public Boolean push. And this guy will take a disk as a parameter. So we'll ask the question if this dot top is equal to null, then we'll just go ahead and say this dot top is equal to D. And we'll return true. All right, so if there's nothing currently on the tower, we're allowed to go ahead and place this guy and we're good. Otherwise, we need to check the top of the tower and say, is this guy's size larger than D's size? All right. Well, in order to do that, we're going to have to be able to get the size of a disk. So we need to have some, because we made these guys all private. So we're going to have to make, give ourselves a getter for size. And while we're at it, why don't we go ahead and get the getter for getter and setter for next disk. So we'll go to source, generate getters and setters. We want a getter for size, and we want a getter and a setter for next disk. Okay, we don't need the display. That's a private variable that we just built once. That way, whenever we call display, it just showed that string rather than having to regenerate the correct number of equal signs. All right. And as an act of solidarity, we will leave this in Emma syntax. So I don't know if I can let that happen. Yeah. Thought for a second. Maybe Van can help you out with that because he'll just take code from anywhere. So he was in my office this morning. He's like, oh, Stack Overflow, the links. Java has a linked list built into it. I'm like, oh, I know that. You don't know that yet. This is what happens when you copy code offline. You're not learning, right? You're just copying other people's stuff and you wonder why it doesn't work. They said it worked. It's like, is that what you ran into?
No,
you kept trying their code and it wasn't working.
No, but probably I didn't copy completely, but I copied the output of how they write about that thing.
So you weren't even good at cheating, is what you're saying?
Yeah, not good at cheating.
Look, I tried to cheat and I just sucked at it.
Yeah.
Well, I guess if there's something to be bad at, it would be cheating. Maybe reinforce the learning process for yourself, right?
And it might just be due to inexperience, which that's a plus.
Or idiocy, in this case. You've met Ben, right?
Yeah.
He's right back there. Disclaimer, I'm decent friends with Van. We eat lunch and stuff all the time. I still don't like him, but he's given me permission to make fun of him. Well, I don't know if you did, but I make fun of you anyways. Yeah, that's fine. All right, what was I doing? Oh, we got our getters and setters and stuff that we might need. Because inside of the push here, if it's an empty tower, go ahead and do the push, move on with life, return true that it worked. Otherwise, we need to take a peek at the top of the tower and say, if the size of top is greater than D's size, then we're okay. We can go ahead and do our thing. So we'll ask if this dot top dot ay, ay, ay. That get size. I hate this keyboard. If that guy is greater than d dot get size, then we'll go ahead and we need to add this guy to the top, which is going to be the same move that we did for our normal stack, where we'll say d dot set next disk equal to this dot top. So have both of those guys point to the same disk, right? So D points to the current top. Then we'll say top, this dot top, that's how I like doing it, is equal to D. So update the top of the tower. And then we'll return true, letting whoever called this know that the move was successful. All right, otherwise, we'll return false. All right, if we wanted to give some feedback, we can, print out an error message or something like that saying illegal move if we wanted to, but right now we'll just bounce it back and say false. That has more to do with foreshadowing a little bit to the second half of class today. We're going to be, after we implement our disk and our tower in the game, we're going to be transplanting those objects over into an Android project and building a user interface for Towers of Hanoi without having to reinvent the wheel. Just our disk will probably, instead of doing a textual display, he'll probably know about I don't know, depending on how we write it, he'll either know about a linear layout or a label or something like that he paints himself in or something like that. Keep your expectations low for how amazing our interface is going to look, but it should look better than our text-based one here. Plus, we'll get back into the Android stuff, which will be good prep for the hackathon coming up, right? Oh, and by the way, we have flyers up, but just as a reminder, if you're, what's the hackathon? April 8th?
Yeah.
Saturday, April 8th. I would save the date on the calendar so everybody participates. We're going to have a 12-hour hackathon here with prizes and free food and stuff like that, where we're going to be we'll have multiple teams making mobile apps either for Android or iOS, so your team gets to decide on what you are going to do. And we divide the teams up where we have some stronger people and then some weaker people. So if you perceive that you're a weaker programmer, you're the perfect fit for the hackathon, because you come there and in 12 hours, you're getting a lot of experience that you wouldn't necessarily get just by doing the grunt work homework over several days. But leading up to that on, is it April 4th?
4th would be the
Yeah, I think it's 6 to 10 p.m. I'm doing a boot camp thing, I think, where we're going to create a simple Android and a simple iOS app that talk to a database. So you kind of will just get a feel for the difference between those two, so that whatever team you're on, if you end up doing an iPhone app or you do an Android app, you'll have a fighting chance of kind of knowing what's going on. So we're going to write the same app twice, both of them talking to the same database. A little simple thing, but just so you kind of get a feel for how those moving parts work. And I will record that, so if for some reason you can't make the April 4th thing, you can rewatch it or watch it for the first time before the hackathon to give yourself kind of a primer. So there's my advertisement for that. And then obviously the Tuesday Bible study, Christian Worldview. Points. Nailed it. All right, push. So if it's empty, go ahead and let it push. Else, if we're allowed to push, push. Else, return false. All right, so that is our tower. Now we probably want a tower to be able to kind of display himself, which is probably going to go through and display the disks that are in the tower, right? So let's go ahead and we'll do public void display. All right, so this is effectively the display method for a stack. Okay, so we'll ask if this dot top is equal to null. Then we'll say system.out.println. What does an empty tower look like? Maybe just a big underscore type thing. So I don't know, something like that. Good enough. That's an empty tower. And actually, we're always going to put this, we're always going to print that anyways, right? So why don't we just say if it's not equal to null, we'll do other printing stuff. And then we'll ultimately print that at the very end after we've done the other printing stuff. So we'll print out our disks first. All right. So we'll say disk cur disk is equal to this dot top. Oop, semicolons in this language. And then we'll say, so we know we have something in here. So why don't we do this? We'll say do. Whatever, let's just write it. While cur disk is not equal to null, which means we actually could have avoided this if statement here. In fact, we can go ahead and do that since we're asking it anyways. So this effectively asks the same question. Only print some stuff if we have something at the top. So we'll set cur disk equal to the top of our stack. While cur disk is not equal to null, cur disk dot display, then cur disk is equal to cur disk dot get next disk. So we'll traverse down our stack, right? Printing each of our towers. We're actually printing from top to bottom, and then we'll put our little, this is the base to our tower, and this is to scale, obviously. Well, I mean, by international standards for Towers of Hanoi professional league thing. So the display will do that. All right. So let's go ahead and let's test this. Get next disk. Is that not a thing? What aren't you happy about? Here we go. Save. Nailed it. Sometimes if you forget to save a file, Eclipse doesn't think it exists. How are we doing over here in there? We started that early. All right. So this will display a tower. Let's go ahead and test that. So we have our 3 disks here. Let's go ahead and create a tower t is equal to new tower. And we'll say t dot push. And we'll push a D3 first. And we'll push D2, D1. That should give us a nice full tower, right? And we'll tell that tower to display itself, and this should be a full tower with our nice little base there at the bottom. Oh man, look, that's like almost perfect spacing, right? And I just basically just sat on the underscore. I mean, sometimes talent is, it's ingrained, is what I'm saying. All right, so that works for a tower. If I try to go ahead and let's do push D2 first, then try to push D3 on top of D2, then push D1, we should actually only get 2 disks out of this, right? We should have the small disk on top of the medium-sized disk, but the large disk would have failed the push there because it wasn't allowed. So there's our 2 disks. All right, so now that we've exhaustively tested that, we'll say it works perfectly. 0 bugs on that guy. So that's our tower. So now we want to have the game itself. So we'll create a new class. And maybe we call this Towers of Hanoi Game. I'm going to regret that name. All right, so here's our Towers of Hanoi game. Towers of Hanoi has 3 towers, right? So we're going to have a collection of 3 towers. Now, when we have a collection of stuff, we usually store collections inside of what kind of structure? An array. Why would we maybe choose an array here instead of a linked list of towers? I agree, an array is the appropriate structure here, but why? Why is an array the better choice here than a linked list of towers?
We always know how many we're gonna
Yeah, we know exactly how many we're going to have. We might as well take advantage of the speed of the array. And because 3 is a small number, we're not overly concerned about that memory footprint, right? If it was 3 billion, then maybe we stop for a second and we consider, okay, well, is the speed as important as finding a place for 3 billion towers sitting next to each other in RAM? Then it's maybe more of a conversation. But 3, I think we can handle 3. All right, so we're going to have an array of towers. Call this guy the towers. Public towers of Hanoi. So when this guy starts off, we're going to create 3 towers. We're going to add those towers to our towers array. And then we're going to go ahead and fill the far left tower, the tower at bucket 0, with the 3 starter disks, right? Okay. So we'll go ahead and we will say, well, first we need to define our tower array as being capable of holding 3 buckets. So there's the towers is equal to a new tower array of size 3. All right, then we'll go ahead and we'll say rect I is equal to 0. This is probably a toss-up whether or not to use a loop or not use a loop here, but well, we're a fan of loops. Plus, then this can generically work for different numbers of towers. Okay, this dot towers dot length.
What is the loop is causing the infinite loop?
How would this cause an infinite loop?
Yeah, what if we don't, the beginner, when they write it, it's just like we or something. Yesterday when I write it, I got an infinite loop.
Okay, so how do you avoid creating an infinite loop? Okay, well, so this is our Boolean expression right here, right? Okay, and for loops and while loops are both pre-check loops. So we're going to be asking this question before we execute the body of the loop even once. So you had an infinite loop because this Boolean expression always boiled down to true. So your question you were asking there never had an opportunity of being false. So maybe that meant that the whatever you were doing to your value here was going in the wrong direction if it was numeric, or you were never changing the value someplace else if it was a while loop. Whatever you were doing, you were causing that Boolean condition never to be false. And it'll just sit there and spin forever. Because that's what a for loop does. A for loop says, do the stuff that's inside here over 0 or more times, because it's a pre-check loop, but keep going as long as this guy is true. All right? So in this case, I'm assuming my tower is going to have 3. I'm going to have 3 towers. We're going to do the simple version of towers of Hanoi. We have 3 towers, so we put a 3 in there. So towers.length will be 3 in this case, so this will go through. But if we did choose to make a towers of Hanoi game with 5 towers or 10 towers, which those exist. I mean, that's the more complex towers of Hanoi. You know, when you get into the upper echelon of professional towers of Hanoi, like I travel the world doing, then you might have more towers and more disks as a starting point. So, you know, the most I've ever done is 7,000 towers and 2,200 disks. I mean, it really wasn't that challenging. It was more tedious. You know what I'm saying?
I was disappointed it only let you go. It only lets you go up to like 8 discs in the game you sent us.
Well, truth be told, would you actually sit there and play Towers of Hanoi for that long? I mean, I only do it for the money. I mean, there is big bucks in professional Towers of Hanoi. You know? Actually, you probably could turn it into like a reality sport where, you know, because there is a known algorithm to it, but do it like on a timer and have the discs, have it be like a physical game and the discs like weigh something, you know, like if you ever watched the World's Strongest Man competition, the thing where they have to, you know, each boulder they have to put up on the wall like weighs more and more and more than the next one. But at the same time as you're like on a platform that's like slowly burning away.
I feel like it could be like a challenge on Survivor.
Yeah, exactly. You know, it's kind of like I saw something on Reddit. I think it was during the Olympics, like how to make certain Olympic sports like extreme. You know, like introduce sharks into water polo. And just have like people in the opposing team just chumming the water. Tell me you would not watch water polo then. I mean, you don't want to see anybody die, but an attack is okay.
Fair.
Right. I mean, they could wear armor and stuff like that, and once they get drug underwater for more than like 6 seconds, they send the divers in to get them out. But I don't need anybody dying to be entertained.
And then we're going to be putting gold medals on caskets.
Well, that's why you don't want to have them die. Yeah, you don't want to put gold medals on caskets. You see, Usain Bolt lost one of his gold medals.
Yeah.
Because one of his teammates doped.
The relay.
It's terrible. Can't even trust your teammates anymore.
I mean, you have to question if he knew his teammate was doing something.
My guess is no. I mean, but who knows? Because then you would ask the same question with the Lance Armstrong. Apparently, at the level that he was doping, he was pretty clear his teammates had to know what was going on. Because I think some of them were. I think they were like donating urine and stuff for various testing. So it's I don't know. That's why I don't run track. I just assume I'd be accused of doping, performance enhancing of some type. That's me. Laundry day?
Yeah.
I actually have a legitimate normal personal excuse.
Yeah.
This shit was
My car broke down.
Your car broke down?
Yeah. I had to get it jumped.
gotta be keeping them like.
Now, if you really wanted that story to be believable, it's my car broke down on the way to the laundromat because my washing machine broke down at home. I think that you missed that was an excuse last semester. He was late to class because he had to do his, was it your brother's laundry?
Yeah.
Well, it's a muddled story because he was doing his laundry, and he refused to go to school, and so it caused this chain of events where
You had to do the
after I
laundry.
came to school, it was like way too late to come from all the way from his school back to here.
So where was the place where you were doing laundry?
I wasn't doing the laundry.
I don't believe that. And even if it's true, I refuse to believe that.
I don't like laundry that much.
All right, so let's go ahead and fill our tower up here. So, we're going to fill our collection of towers up with a bunch of empty towers, and then we'll fill the leftmost tower up with some discs. All right, so kind of 2 steps here. So we'll say this dot, the towers at bucket I is equal to a new tower. All right, then we'll go ahead and we'll say for int I is equal to 0, I is less than, we'll just put a 3 in there because that's the number of starting discs. If you wanted to have a different number of starting discs, you could. Let's make it generic, just cause. Make this guy private while we're at it. Private num starting discs. This guy's going to be an int. And we'll go ahead and set num starting discs equal to 3, which means that this loop down here will go num starting discs number of times, I plus plus. And now we're going to create new discs we'll create new discs and add them to the tower. All right, so we're going to add the largest disk first down to the smallest disk. Okay, now I guess we can do this several different ways, but for the time being, let's just go with int start size is equal to, let's just make it work. So we'll say 9. And then we'll keep subtracting 2 from it each time through. So we'll go ahead and say this dot, the towers dot, at bucket 0 dot push a disk. What disk? A new disk of size start size. Maybe this should say cur size instead of start size. Then we'll say cur size minus equals 2. Is that right? Is that what I did before? I do 975.
963.
963. Okay, so we -3 then. All right, nailed it. So this will go through and push the large disc onto the first tower, then the next smallest one, and then the next smallest one, kind of set up our towers. So the constructor for Towers of Hanoi sets the starting point for our game. That's what a constructor does, right? Says, here's a collection of towers, here's a tower, here's a tower, here's a tower, then I put some discs on that first tower. That's what we've done here. Okay? Then we probably want to teach the Towers of Hanoi game how to show the current board, right? So we'll have a public void display. And this guy's going to go through each tower and tell each tower to display themselves. Okay? So we'll go ahead and we'll say why don't we do a for each loop for this one? It'll be exciting. Okay, so we'll say for tower T in this dot the towers T dot display. All right, so this is a for each loop. Each time through, T will be the next element inside of the towers. And we'll tell that particular tower to go ahead and display themselves. Okay. Now we might want to, just so we have a starting point, we might want to give like a number under each tower, maybe 0, 1, 2, something like that. So maybe what we do is we say something like int pause starts off at 0, and after a tower displays itself, we do something like system.out.println. We'll just put a number in there. So we'll put pause, and then we'll increment pause. So that kind of labels the towers as this is tower 0, this is tower 1, this is tower 2. It's not going to look pretty. It'll just be left justified, whatever. But it is what it is. All right, and then let's also, after we print that out, why don't we go ahead and we'll concatenate onto that. Maybe a couple of carriage returns, just to add a little spacing between our towers. So we can see a tower, then another tower, then another tower, not all just melded together. Again, this is just human eyes only type stuff. All right, and so this should show the current state of the board. So it's going to make each of our towers display themselves. After each tower, we'll show the kind of the tower number for that guy. That way, when we do our user input, we'll have something to reference. Where am I popping off of? Where am I pushing onto? That type of thing. All right, so now let's go back to driver. Get rid of all this stuff. And we'll just say tower T. I'm sorry, not tower T. I thought I copied that. All right, so Towers of Hanoi game, TOH equals new Towers of Hanoi game, and then we'll say TOH dot display, and that should show our starting game grid. So the first tower has all of our discs on it, the next tower has nothing, the next tower has nothing. Make sense? All right, so that's our starting point for Towers of Hanoi. Okay, so now let's go, and we actually need to be able to play the game now. So playing the game is going to ask the user to pick the source tower, right? Then pick the destination tower and attempt to make the move. So we'll have our public void play. We're going to need to get some user input, so we use our scanner for that, right? So we'll say scanner input is equal to new scanner built with system.in, which is the keyboard. And this guy wants us to, is it option enter? No. Shift up, shift up. No. What's the command? Isn't it I thought that was a shortcut. Oh, it probably is. Whatever. All right, so for right now, let's just do while true, since we don't have a way of checking for a winner yet. So we'll just let them keep making moves, as long as they want to make moves. All right. Good programming practice would say we should probably define our source and destination variables outside of the loop rather than redefine them each time through the loop, although most modern compilers have some optimizations where they'll let you define a variable over and over again inside of a loop and kind of make it as if you did it in an intelligent way. But I'm going to define them outside, so we'll say int source, int dest, and then we'll do a system.out.print enter source tower. We'll say source is equal to input dot next int, so it'll read in the next integer, and we'll assume the user is going to use our interface correctly. We don't have to check for them putting in letters and stuff like that. So in a real life situation, you probably should, but let's not spend time doing that. Then we'll ask them to enter in destination, enter dest tower. Okay, so dest is going to equal that. All right, then we'll try to make the move. That make sense? Try to make the move. So what we'll do is we'll say this dot the towers at bucket source. So that's the tower we're popping off of. So we currently don't have a way to pop. So we need to go and teach a tower how to pop a disk off. Public disk pop. Okay, what's this guy going to do? He's going to return the top of the tower, but then he's going to update what top currently is, right? So we're going to say disk to return is equal to this dot top. All right, then we'll say if this dot top is not equal to null, then we'll set this dot top dot set next disk. I'm sorry. This dot top is equal to this dot top dot get next disk. Like that. So as long as the top of the tower is currently not, null, we'll go ahead and update the top of the tower to be whatever the next disk is, which might be null now if there was only one disk on there, but might not be. All right. Then ultimately we will return disk to return, keeping in mind that the disk we just returned might be null. Okay, we may have returned a null disk. All right, so after we read in the source and destination, we're going to try to get probably the source disk and so let's create a disk here called source disk. And we'll go ahead and say source disk is equal to whatever happens when we try to pop off of the source tower. If source disk is not equal to null, so if they gave us a legitimate disk, right? Otherwise, if you tried to pop off the empty tower, We don't want to try to push null onto any other tower. So as long as they gave us a legitimate disk, it's been removed from the source, we're hovering over here with it. Okay, we're going to try to push it onto the destination tower, but we're going to be very interested in the answer that it returns, whether it said true, it worked, or false. So if not this dot, the towers at bucket dest dot push source disk. So by saying not in front of that, this is saying if this did not work, that did not work, let's go ahead and push it back where it came from. Undo the beginning of our move. All right, so by putting not in front of this, this is the same thing as saying this. If when we tried to push the source disk onto the destination tower, it returned false, which means it did not work. Okay? So this is the more efficient way of writing that. Otherwise, it's redundant. To say is false equal to false. Saying not true. Okay, so if this guy gives us something other than true, then what we're going to do is we're going to say this dot the towers at bucket source dot push source disk. So we'll go ahead and put it back where we took it from. And we don't have to check that one. We know it works because we just took it off of there, right? So as long as the disk we tried to remove was a legit disk, then we'll try to push it on the destination, and that will either work or it won't. If it doesn't work, we'll go ahead and put the source disk back where we found it and move on to the next move. At the end of our move, regardless of what ended up happening, we'll go ahead and we will show our towers. In fact, we probably want to show the tower, we'll say this dot display right at the beginning. So we see the current list, right? We see our current board. Then we choose our moves. Then whatever happens, happens, and we show the updated version of the board. So let's go ahead and call toh.play. So this should allow us to manipulate the board, make all sorts of moves, that kind of stuff. All right, so here's the current state of things. So enter our source tower, we'll choose 0. Enter our destination tower, let's choose 2. Ruh-roh. Looks like I have a lot of stuff on tower 2 now. Didn't quite get everything. Remember a while ago I said that I like to make sure I disconnect disks? Fully disconnect. When we pop here in our tower, when we remove this guy, we set this dot top equal to this dot top dot get next disk. Well, this guy did not necessarily, and the same thing goes with push, get his next disk reset. So before we return disk to return, this guy down here, we probably want to go ahead and say disk to return dot set next disk to null. Fully detach him from the list. Because otherwise what ended up happening here is what used to be top was still pointing to the second disk. And when we pushed it onto the empty stack, an empty tower, we never set his next node. So his next node still pointed to an old disk. So this will fully detach him. So this is the guy we're gonna return. Then we'll go ahead and update top to be the correct new place. And then we'll make sure that the disk we're about to return gets fully disconnected from the stack he used to be on. That make sense? Otherwise, these are just linear linked data structures. So this guy right here used to, even though he was technically on this stack, he still pointed to this guy, which still pointed to this guy. That's why they were showing up in that last stack. So they weren't actually members of that last stack. These were just all memory addresses. Okay? So then the next move, we'll go 0 to 1. Then we'll go where's my tower? Okay, yeah, that is the middle one. Okay, good. Then we'll go 2 to 1. Then we'll go 0 to 2. Then we'll go 1 to 0. Then we'll go 1 to 2. Then we'll go 0 to 2. Now that should be a winning position, correct? So we're not stopping now. It's going to let us keep manipulating things. Now we can go from 2 to 1, and things are still moving around. But now our board seems to be dynamic, right? We're playing the game. Okay. So how do we check for a winner? Because really, instead of, when we in our play method up here, wherever we are, we're in Towers of Hanoi. Right now, we're just saying, yeah, go ahead and let them just keep moving, just forever, while true. So there's your infinite loop on purpose, Van. This is the ultimate infinite loop. Okay, while true, just true is always true. Okay? It's a Boolean literal. This is just going to go forever. All right. So we put that in there as a placeholder for testing, but we really only want them to be able to play the game as long as there's not currently a winner. What does it mean for there to be a winner? Okay, either first 2 towers are empty, or tower 3 has the maximum number of discs in it. All kind of the same thing, right? One issue we have right now is we don't have a way of towers reporting how many discs are in there. So might be convenient for a tower to be able to give us our correct number, right? So that means any single time we push or pop, we need to keep track of a count. So when we pop, only if we actually reduce the size of the list. So in the case where we're just return the null from the top, we actually didn't pop anything. But if we did change the size of our tower here, then we'll say this dot count minus minus. And then in push, if we add something here, great. If we add something here, great. So wherever we return true, we can increment count, but not when we do false. False means it was not successful. All right. So we'll say this dot count plus plus, this dot count plus plus. All right. Then we want to go ahead and give ourselves a get count, the ability to ask a tower for his current count. So source, where's source? There we go. Generate getters and setters. And we don't want to be able to set count, but we do want to be able to get the count. So this lets us read the current count.
Don't we want to be able to set count on tower 1 to 3 beginning?
It'll get set himself.
Oh yeah.
Because we're pushing. Yep.
Right.
Now, if you had added it differently, so it's possible that's coming from the way you implemented it. You might have had a tower taken in the constructor or something like that, the number of disks to build.
They it filled through a for loop based on, and I won't explain it, but
yeah, I get it. Yeah, but I understand where that question came from. But in our case, we happen to be using our push mechanism to fill that tower at bucket 0. So over here in Towers of Hanoi, we're actually pushing those disks onto the tower, and push manipulates our count variable. So it'll naturally bump to 3 after 3 pushes. Otherwise, you would need to be able to set your count. You'd have to be able to do that. But we only need a get count here. So what we really want to say here in Towers of Hanoi is, inside of our play thing, is we want to keep going as long as the last tower does not have num starting disks, number of disks on it, right? as long as last tower's count is less than num starting discs. Because num starting discs is what we put in for the number of discs that we should put in the far left. So instead of while true, we're going to say while, where's the last legal tower? Right now we have 3 towers, so the last legal tower is bucket 2. But generically, you can say this dot the towers at bucket this dot the towers dot length minus 1. That's the last tower, right? So while this dot the towers at bucket this dot the towers dot length minus 1. So this guy right here is going to be boiled down to the last tower. Dot get count. So we're going to get the count for that tower. While that number is less than this dot num starting discs. All right. So this relatively long Boolean expression here just says, while the far right tower's number of discs is less than our starting number of discs. That means that all the discs are not on that tower yet, which means that we don't have a winner yet, which means that we should keep going. Make sense? All right. So while that's true, keep doing that stuff. Otherwise, we should finally spit out winner. Let's go ahead and run this. Okay, so we'll go 0 to 2, then we'll go 0 to 1, 2 to 1, 0 to 2, 1 to 0, 1 to 2, 0 to 2, and there's our winner. Probably want to show the game board one last time when we have a winner, but you get the point. All right, questions about that? Go ahead.
Can you go back to the display method for this?
And remember, this guy's just printing out the variable that we built inside the constructor up here. So we actually built that variable display when we first created this disk using this for loop right here. So he's just some number of equal signs. All right, so let's, should I put that on, well, I don't want to put all those in GitHub. Let's paste these in Slack for now, and then but we'll start putting our Android stuff on GitHub. So slow. See, told you, get a Mac. You want infinitely slow scrolling speeds? It's awesome. I didn't have that before.
There's actually a lot I like about macOS.
Well, obviously, dir. What is tower.java? At the end of the day, I think it's just whatever you get used to, because then you know all the shortcuts for it.
I think the one difference though is that, I don't know, it's kind of like a catch-20 type of thing. 'Cause I learned macOS with the idea that I wanted to know all the keyboard shortcuts right away. Where in Windows, I learned Windows when I was a kid, so I didn't learn the keyboard shortcuts right away. And I still do think about keyboard shortcuts sometimes.
Sure.
Stupidly.
Well, I don't know if that's necessarily stupidly. It depends. You know, like one issue I have with, this is actually an irony, a programming irony, is doing iOS programming on the new MacBook Pro. Pretty commonly, you are hitting control and dragging between two view controllers to connect them together. Well, you know how most keyboards have 2 control keys, right? So your keyboard has a control key on the left and the right side, correct?
It's command key. Only one.
You only have 1 control key?
I
Is that
actually-
13 or 15 inch?
15.
I have 2 control keys.
I really thought, what year is your 15 inch? Mine was a 2012, and I had 2 control keys.
It's later than 2012.
Okay. So really, she's saying Apple's been screwing programmers over for a while. Because the issue is that in order to go from, and it makes it even worse with the Force Touch. So my laptop from 2012 didn't have the Force Touch trackpad. It had like the normal, I mean, it looked the same, but it wasn't the multiple pressure things. So what I end up doing on iOS now is when I'm trying to do control click, I have to like cross over, okay? Because I use the, I guess I'm just used to using the mouse in my left hand, but I can do it with either. But I'm left-handed, I suppose. But the thing is, when I'm doing that, it's like hard to just do a click and drag instead of a click, press, and drag, which is a whole different thing. So I really feel like I'm using the computer, but just not always accurately. The slowest part of my programming now is keyboard related.
Do you usually program on that? Or
Oh, yeah, on this.
Oh,
Yeah, that way I can
Okay.
lay on my massage chair and write code. Durr.
Makes sense. Not all of us have a massage chair.
I know. It's awesome. But you've seen the lap desk I have at the house, right?
Yeah.
That's what that's for. They're awesome. Those articulating lap desks. Oh, you have to get one of these. Let me show you. Let me show you this thing. That's not the site. See, I hate the keyboard. Laptop, lap desk. I think it's probably articulating. No, that's not it. But yeah, these types things. Because you can bend this in all sorts of different directions. So each of these joints has, they lock into position. So I don't keep it in this position. I have it in the position where it's like, this one is all the way back. Then it's this next one here. Then it's this one here. So that sits on the top of each of my legs. And then this here is just shifted up a little bit. So it's like a normal desk. Doesn't matter what position you sit in, you can adjust it to be right. I do all my gaming now from the massage chair. Except I can't heal in World of Warcraft on this. I can DPS, but I can't heal. Too many buttons you need the extra mouse buttons for the different healing spells, but DPS, I just do everything with a macro, so it's... Okay, so that's Towers of Hanoi on there. So let's start our Towers of Hanoi game on Android, and then we'll have you guys fill in the blanks. Because let's see, everybody in here had Android with me last semester, and you said you've had a class on Android, right? Okay. So we'll start a new Android Studio project. We're going to call this guy Towers of Hanoi. Click next here. That's fine. We'll just use the default stuff. Dun, dun, dun. And I like to start with an empty activity as opposed to the basic activity because I don't like having to delete the crap here. So pick
Pretty much always started with my class.
on the empty, yeah. And have you done iOS stuff?
Mhm.
So I always start with the single view application. All right, so we'll call that guy main activity good enough. So when we think about Towers of Hanoi here, we have to be able to somehow visually represent 3 stacks, right? So we probably want to have our 3 stacks being represented as maybe 3 vertical linear layouts. Those guys almost kind of will work as stacks, right? When I stick something in there, it just, you hear those, that's sound effects. I mean, they actually got stronger as they went. Usually you start losing air. Okay, so we'll go ahead and build our interface here. in theory. Okay, so let's go down to our resources, our layout. So let's see how much stuff has changed since the last time I used Android Studio. Okay, I can minimize this dude, right? Ah, nailed it. All right, so let's get rid of the hello world thing. Typically, these guys are still a show me what's there. Where's my, was that the guy? No. Where's my component view that shows me these pieces? Well, it's a relative layout.
Component trays below the palette.
No. I want to see the layout of this because sometimes it's easier, you know. So if you go to the text of this, you can see that this is a relative layout, but there's a view that shows you that, you know, it's like a list view of this stuff. I really thought it was under properties. Oh well, at some point I'm sure I'll just click on it. So it'll work out. Because sometimes it's easier to land on that than it is to drop something in here. But what I like to do right off the bat is I like to throw a linear layout, usually a vertical linear layout, onto the whole screen. Yeah, maybe this is the new version of it. I don't like that, but whatever. Okay, so I throw a linear layout onto the whole screen like that. Now, for us, what I'm kind of thinking about for our interface here, and you can make your interface however you want, I'm thinking we'll have the 3 towers at the bottom, and each of those towers is going to be a vertical linear layout. Okay? And maybe we have a button above each of those towers. That way you don't have to handle the, clicking on an individual view or something like that. So just deal with button clicks, the stuff that we've dealt with before. When you click on the button above Tower 0, what that's going to do is it's going to pop something off there and maybe put in the, show the disk that you currently have selected up top here. So we're going to kind of have like a placeholder area up top that you will click on. And, you'll click on this, which will pop it off the tower. So the tower will look one smaller than it used to be. You'll have your little placeholder sitting here. That's the disk you're about to place. And then when you click on one of these other buttons, it'll push it onto that tower if possible. Otherwise, it'll put it back. All right. So just to kind of get the ball rolling here, in order to do that, we're going to have kind of 2 different things here. I'm going to go ahead and I'm going to throw a... How am I going to implement my towers? I guess let's do this. We'll have a horizontal linear layout in here. And then I'm going to have this is what I was looking for, my component tree.
That's what I said.
Oh, you were lying to me. Didn't that used to be over here?
Yeah, last semester. But we had this conversation last semester where you said it used to be somewhere else.
Oh, really?
Yeah.
I'm old, dude. It's bad. See, I had breakfast 2 hours ago. I don't remember what I had. I sort of remember eating a tater tot, but I'm not sure. I'm just not sure. I just don't know. All right, so then I'll drop this guy down here, so that's kind of easier to drop stuff. So now I have a horizontal linear layout here. I have a horizontal linear layout here. And then I would probably put a couple of vertical linear layouts inside of this bottom one. So these guys are going to be indented inside of that guy. Okay. So if you kind of think about how this works, and we'll lay this out a little bit with, let's just say, some buttons for right now in our last minute. we need this guy to have equal distances, right? Because this guy is a horizontal linear layout. I have one button in there. I'll go ahead and throw a button in each of these just so it shows them next to each other. And then we need to, because we want to see those guys as 3 separate stacks. Okay, so we'll keep working this, but for your homework for Monday or Tuesday, homework for Tuesday, get back into Android Studio, get everything updated, design a placeholder interface for Towers of Hanoi. Doesn't even have to work yet. Okay? Doesn't have to work yet because, you know, you're going to be rusty with this. So effectively do what I'm doing here, where if you want to make your interface different than this, that's fine. Okay? But effectively what I want to have when I'm done here is I want to have 3 buttons stacked on top of each other right here, 2 empty towers next to it, kind of a placeholder guy here, and, you know, with the concept that maybe there's 3 buttons above. And when I click on one of those buttons, something pops off here and goes here. You don't even need to make the popping part work. Just design your interface and put some buttons or some labels in there as placeholders to kind of show how it all lays out right. All right? And then submit a screenshot of your mocked up interface, but mocked up in Android Studio, not, you know, written on paper or something like that. That make sense? All right, so do that for Tuesday, and then we'll actually integrate Towers of Hanoi into our interface on Tuesday. All right, have a good weekend.